Despite its mechanical simplicity, or perhaps because of it, there's no denying the utility of a metal cutting bandsaw to the subtractive machinist. I mean, it's easy to get caught up in the wonder of roughing on a milling machine, or the whimsy of blue chips flying from a lathe. But whether the part's round or square, there's a pretty damn good chance it'll start its life at a bandsaw. From simple docking to highly selective bulk stock removal, the only real limit to a bandsaw's capabilities is your imagination. And, of course, the saw itself. So I'm going to build myself a better one. See, most metal cutting bandsaws on the market today, at least as far as the home game is concerned, take the horizontal approach. The saw is mounted to a frame alongside a vise, so it can pivot through whatever piece of tube or bar might seem a little too long for the task at hand. This is a pretty good approach if all you're doing is turning long bits of stock into shorter ones. But for tasks with a little more nuance, it's a lot better to have the blade move through the material in a straight line. Now, obviously vertical bandsaws are a thing, but just slapping a fixed table on the saw and calling it a day makes the assumption that the operator has the time to stand around pushing solid material through the blade all day. If you've been around here before, you'll know that this isn't my first attempt at building a better bandsaw. But I'm not an engineer, so it usually takes 1 or 2 goes to get things right. One of the biggest challenges the first time around was designing around the already existent saw itself, a form fraught with irregular geometry and highly inconvenient obstruction, making the task of modelling it up in CAD too much of a pain in the ass to sit down on. The end result was a hodgepodge of parts, born of manual machines and anxious offer-ups, and held together with not much more than the most aspirational of my hopes and dreams. But apart from its numerous inadequacies that we'll certainly touch on shortly, the additional functionality achieved by adding a linear axis to the saw was, quite frankly, intoxicating. And from the very first cut, I knew I'd be walking this path again, with just a little more forethought and infinitely more lasers. I've got a feeling that this is going to be pretty exciting. The desire to use a 3D scanner has been with me for almost as long as my unhealthy obsession.
Oh, yes.
With machines that bring parts from the digital world into the real one. So when Creality reached out with the offer of a no-strings-attached Surmoon S1,
It's pretty handsome.
along with a wireless scan bridge, I was more than a little weak in the knees at the thought of finally being able to bring parts from the real world into the land of make-believe. So once I'd disassembled Old Faithful and plastered the casting in tracking markers, I got to work on digitizing the saw. Now, I'm still fairly new to the process, and that fact, coupled with my decision to capture at a frankly absurd resolution of 0.02mm, meant scanning wasn't exactly quick. But after I'd captured all the critical details from several sides, I could combine them into a more than adequate reference and get to work on the rest of the design. One of the biggest drawbacks of my last attempt at building a sliding bandsaw table was, believe it or not, the sliding table. I mean, don't get me wrong, for small pieces of material, it makes sense to have the work travel to the tool. But as soon as you need to lop 25mm off the end of a 1.6 metre length of 80mm round bar, the romance starts to fade. So this time around, I wanted to turn the tables and have the saw do the walking. Initially, and as per usual, I fell squarely into the trap of designing around the material I have on hand. But it only took half a minute or so of staring at this rusty old bit of plate to once again seek alternate means of plate part procurement. Version 2 was cobbled together with the intention of getting all the big bits of plate laser cut. I had no idea how much this was going to cost, but given the amount of material I'd have to remove from an off-the-shelf piece of plate, it'd certainly be worth the time spent finding out. Thankfully, with Onshape's Git-style version history, every change is stored in real time. That means my original design stays safely tucked away in the cloud, ready for reversion at any moment. So if you need a design tool that keeps your options open, click the link in the description and try Onshape Professional free for up to 6 months. In the end, the quote ended up being ludicrously affordable. At just under $300 Australian dollars, it was barely more than the cost of the raw material. But we'll get back to those laser cut parts, as well as the cleverly compact power feed mechanism a little later on. For now, we should really get to making some parts. And what better component to kick things off with than the central frame of the saw, which starts out as a piece of 100 by 25mm flat bar, predictably a little too long for our purposes. So after marking our length, it's over to the bandsaw.
Oh yeah.
Not to worry, it's for this exact reason I like to keep a spare bandsaw. Or two. But without the coarse teeth and freedom of work holding I'd become so used to, things were not going well.
Something's gone weird there.
And my desperation to separate this stock,
God, this sucks.
squarely and without fuss, led to a number of questionable solutions.
Probably a bad idea.
But if you throw enough of those at the proverbial wall, you might eventually end up with a setup that has you questioning the need to build such a complicated bandsaw table in the first place.
Well, that worked way better than it should have. Makes me almost question why I'm bothering with this table build.
Now, my approach to all the parts for this machine is a little different than usual. Ordinarily, anything less than machining every single face and feature would leave me feeling a little itchy. But I mean, it's only a bandsaw. Plus, hot rolled material usually has a bunch of internal stresses, which tend to turn even the scantest of facing cuts into a banana bending bonanza. And I know it's only a bandsaw, but it would be nice if, in the end, it's able to produce something at least resembling a straight cut. The first operation focused on mounting points for the main linear guideways, tasked with supporting the saw along its length of travel, as well as a reference surface, which would allow the table to be mounted true. And the second side was peppered with features geared towards attaching my peculiar approach to a power feed. By this point, the laser cut components were ready for collection, and so I collected them, eager to inspect the fruits of my not labour. I find it truly remarkable that, for such a low price, I'm able to get 16mm plate, cut to the exact profiles I'd sketched up just days earlier. And I do mean exact.
Made a mistake on the sketch for that one.
But laser cutting is still a fairly two-dimensional process, and as is the fashion, my plans call for one or two features that take full advantage of the universe's apparent Euclidean geometry. The plate responsible for connecting the saw to its table might not be the best example of this, but simple as it was, I still felt I could do with some supervision from a German with quite some experience in revitalizing machinery. At least that way I'd have someone to blame should things go awry. I really can't overstate the importance of a convenient scapegoat on projects like this. But if you're working with a team, it can be hard to keep track of who's supposed to be doing what and when. That's where today's video sponsor Odoo and their all-in-one business management software comes in. Odoo's project application enables effortless organization by providing a comprehensive view of all your projects. Whether you're dragging tasks like sticky notes in the Kanban view, mapping dependencies with the Gantt view, or batching actions in the list view, Project keeps your priorities organized and your tasks on track. It's dead simple to create tasks, schedule activities, and even set up reminders that sync with your calendar. And using the timesheets application, your team can easily record information like time spent on tasks that can then be used to track costs and budgets in real time and even directly bill clients. With the chatter, you can send emails, add notes, and attach files, keeping all the critical info in one place and everyone on the same page. So to make sure everyone knows what they're doing and when they're doing it, try Odoo today. Use the link below for free lifetime access to your first application with unlimited hosting and support. Fortunately for Gerolf, this part turned out great, so it was onto the table and its T-slot like trenches. Now for all the raving on laser cutting I've squeezed into this script, there's still a few challenges presented by the process that bear mentioning. First of all, literally vaporizing steel with light does have a tendency to introduce some heat to the part, which can result in something of a bow. This won't be too much of a problem, thanks to the reference face we machined into the frame. But to make sure there's good contact, and all the other features are true to this reference, I'll clamp the table nice and flat before milling something of a slot down the middle. The next challenge was hardness, and I don't necessarily mean difficulty. See, while having these eye slots laser cut definitely saved me some time, it also left the edges harder than a dingo's donger at dawn. And while this end mill certainly did an admirable job, I knew there had to be room for improvement in my approach. So for table piece number 2, instead of climb cutting, which forced each flute to contact the case-hardened edge at full tilt, I gave it a lick in the conventional fashion, allowing the cutter to peel away at the shell from behind. With my tool life preserved and my not quite T-slots contoured, a quick test fit of the table to the frame revealed my plan to achieve flatness had worked flawlessly along the length of the plate, but left much to be desired across its width, where, when it comes to consistent clamping and squareness of cuts, flatness is at least twice as important, so it was well worth some time at the press to get things straightened out. By now, the weight of the assembly was really starting to add up, so I decided it was time to get everything mounted to its base. The rather specific geometry of this pivotal component is as much a product of stock on hand as it is of carefully considered clearances. So I lopped off a short section of SHS and began marking my cuts. With the core cleaned up, I cut an assortment of small plate pieces, quickly shaping them on the radius master so they'd fit neatly into the square tube. These pieces should give the square tube a bit of its stiffness back, as well as a little style, which, as we all know, is one of the core components of good machine design. To mount it to the drill press stand, I picked up some hollow bar because using solid bar would have been a lot more boring. I didn't quite get the fit right from the first side, but after flipping and finishing the other end, it slid on like a dream. Yes. Then I could weld it onto the square tube section and add a threaded lug for locking the table in place.
Found the die cam.
Now, if you're having doubts about the stability of the thing, with all that plate suspended above such a small footprint, You wouldn't be the only one. But the priority at the time was to make sure the project hadn't been a complete waste of time. So we'll get it cutting first and worry about it falling over at a later and as yet undetermined date. So next up, I have to make the pin to mount the bandsaw to the new sliding table. I've got this from the old setup, so waste not, want not. I'm just going to trim it down and add a couple of holes and it should fit right in. This really is the moment of truth. I hope everything lines up. Come on. Beautiful. As with all one-off machine prototypes, this is sure to be only the first of a long and prodigious line of assemblies, disassemblies, and reassemblies. I mean, for starters, these black oxide fasteners simply won't do in the long term. Aside from aesthetics, the first assembly and subsequent use of a pipe dream such as this will almost always uncover the most obtuse of issues never even considered during design. And especially when working with pre-existing components.
Well, that worked pretty well.
It's easy for the most innocuous assumption to spoil your entire day.
Hang on a minute, what's going on there? Well, you can see the problem from a mile away. That blade's cockeyed.
How I never considered that the blade wouldn't track parallel to its OEM pivot is beyond me. But there's a lot left to get done before we come back to address this properly. I mean, we haven't even started on the power feed. So for now, a frankly embarrassing stack of shims will see us through. To make use of the open bottom T-slots, I'd of course need some T-nuts. And while it would have been clever to design these features to fit a standard size nut, my over-eagerness for a laser cutting quote and initial under-enthusiasm for milling laser cut edges had me left with slots that were slightly larger than the usual 12mm. On the plus side, I'm not likely to ever lose these nuts, simply for the fact that they're not compatible with any other machine on the planet. There's obviously more to the work-holding elements of this machine, but by this point, the lack of power feed felt more of a pressing issue, and parcel by parcel, the pile of air-powered components intended to address this was now almost entirely complete. The only thing missing was the most important part of all, the 40mm cylinder charged with driving the saw forward. That's too fucking big.